Welcome all, thank you for tuning into my channel. If you are new to this channel, please don't forget to subscribe. And if you have any doubt or any query regarding Abaqus, please do contact me. I have given my contact details, my phone number as well as my WhatsApp number. My WhatsApp number has been given and my email is also available. So if you want to contact with me, just contact through email or through WhatsApp. Then we can discuss about your problem. You won't be able to call in this number because I'm not using this number. I'm using this number as for WhatsApp only. So if you have any doubt or any query, just don't forget to contact me, and please do subscribe my channel. So today we'll be modeling this problem. So fly ash have been used in place of concrete, with concrete, not in place of concrete. So for that I have drawn the center line diagram for this beam. That is, all the dimensions that I'll be taking in Abaqus model will be calculated using the center line diagram. The cover, top and bottom cover, have been taken as 25 mm and 25 mm. Side cover for this beam, top and bottom cover is 25 and 20. Side cover is 20 mm from each side. And from longitudinal side, the bars are placed at a distance of 25 mm from each side. These block size have been given here, 100 by 6 by 100. So I'll be taking these blocks for assigning the load. So let us start. As I have mentioned, I have taken the center line diagram. So if you just consider the top and bottom cover as 25 mm and side cover as 20 mm, along with the longitudinal I would say longitudinal distance from each end to the bar end is 25 mm. So let us start first with creating the beam. I'll be working on mm, so I'll make it 6000. So I'll draw first the cross section of the beam. The width is 100 and depth of the beam is 200. I'll move this beam to the center so it will be easy for me. Even if you don't move it to the center, it will work for you, but just for for easiness, just want to have this beam at center. The total length of the beam is 2000 mm, so I'll give it 2000. So we have here our beam. Next we'll be modeling the longitudinal bars. Top, it will be wire, same. I'll make it vertical. The longitudinal bars will be of I'll have to check it. It is, if I just keep 25 mm spacing from each side, then the longitudinal bar will be 1950. And over here, as you can see, some bands have been provided, but we do not have any data for that. So it takes some, you can take the development length for it, you can calculate it, but randomly I'll assign some value. Let's see if I take 50 mm. Yeah, I hope this will be sufficient. Yeah, I think 50 mm is sufficient. So this is the top bar, and I'll just copy it to make the bottom bar. Next we'll make our scale-ups. I'll make a rectangle. As I mentioned earlier, I have calculated the center line distance, so it will be 60, keeping spacing of 20 from each side, and it will be 1 50, keeping spacing of 25 mm from each side. I'll again move it to center. So everything is done. I'll go to the property. I'll simply create concrete density. I'll assign as 2500 kg per meter cube. Meter cube, it will be e raised to the power mm cube minus 9, because 2500 is kg per meter cube. So in mm cube it will be, this will at denominator it will be 9, so it will be minus 9. Next, elastic. Let's check what is the elastic property that has been taken here. Yeah, parameter for concrete. So if I just consider this one, it is 20.13 GPa. 20.13 e raised to the power 3. Why e raised to the power 3? Because 20.13 is GPa and MPa is nothing but Newton per mm square. So here I have considered it. Next, the Poisson's ratio value 0.22, and that's all. Okay, density they have given 2400, so I'll take it as 2400 instead of 25. Over here everything is given. Okay, now you can use this FCT if you are going for concrete damage plasticity. Here I'll consider it as elastic only. Concrete, I'll simply copy it. I'll rename it as steel and I'll edit it. Density will be 7800 e raised to the power minus 9, same. Elasticity will be 200 GPa, 200, 3 more zeros to make it MPa, and Poisson's ratio is 0.3. They have given the yielding stress, so if you want you can simply go to this plasticity, go to plastic value. Yield stress will be 410 MPa, 410, and elastic plastic strain will be 0. So that's all. Material definition have been completed. I'll assign the sections. First assign the stirrups. Let's go here, select, name it as stirrups, to get truss. Cross section area will be 50.2656. Done. I'll go to the longitudinal top bar. I'll create the section, select it, again go to beam, name it, and select steel. The top bar will be 8 mm dia, so it will be again 50.2656. Select the top long. The bottom, yes, bottom will be this one. Go here, select bottom, longitudinal bar, select the steel. Cross section will be 78.54 meter square. 78 point, bottom longitudinal. Done. Now we have this concrete. Assign it. Go here, select concrete, go to solid, homogeneous, concrete. Done. So all the material property have been assigned. You can save it as fly ash. Done. Now next I'll go to assembly. I'll simply take everything there. Yeah, I will take this and this. Yeah, I can take all this all together, but I just don't want to take this top bar. I'll take it later so that I do not get confused while modeling it. So I'll have to first hide it. Go here. You can do it from left side trim menu also, but I always prefer to use this. I'll hide the beam. Now I have these stirrups and longitudinal bottom bars. So first I'll rotate this one. I'll rotate it about x-axis. So just give any value to make x-axis. I'll rotate it 90 degree. Done. Now as it is bottom bar, so I'll have to again rotate it. I'll have to rotate it about z-axis. So first with this it will be 0 0. Okay, 90 degree. Done. Now I need to translate it. My computer have become little slow because the recording is also going on. Then select this point, come here. I'll delete the one stirrups later on, but not now. Now again I'll go here. I'll bring the top bar. I'll have to rotate it again. Select to make first axis. Done. Now again I'll have to rotate this, the top bar that I have just bring over here. Then select, I'll have to rotate it about z-axis. Okay, so I need this one to be downward, so I'll rotate it minus 90 degree instead of plus 90 degree. Done. I'll bring out over top. Select this part and bring it over here. Done. Now I'll copy this top bar and bottom bar sidewise to make another two bars. This one and this one to be copied. Just avoid this warning, make it one. So if I just increase it, okay, this is my lateral and this is my vertical, so I don't need vertical, I need lateral, and I need only two. The spacing would be, it is 60. Yes, so it is done. Now I'll copy this reinforcement bar longitudinally. I just make it one, select the direction in this, and the spacing will be 150, and the number will be 13, 14. Okay, I need 13. If you just check here, so even they haven't mentioned what is the end distance, so I'll make another one, and what I'll do, I'll simply translate it little bit around 100 mm or 50 mm on the right hand side. So I'll translate this point to, I'll have to find out the coordinates of this point. So this is the coordinate that I'm taking to make sure that it remains horizontal and the point where I want it to be there. So I'll just press this point and I'll modify the z direction. So z direction it will be, it is 1950. So I'll make it 110. Let's copy it. Okay, so it looks quite fine. I've just moved 50 mm. That's all. Same I'll have to do on the other side. This is just to make sure that it should become like this, because we haven't, the data is not available. Same I'll have to check. I'll have to first select this point, then I'll have to find out the coordinates of this point. It is 30, so just cancel it, make it it will be 5. Okay, sorry, not 5, it will be 50. It will be 50. Done. So we have our reinforcement. Now unhide the beam and simply place it at our required point. Now if I just take this view, I think it is not correct. So what I'll do, I'll again hide this beam and I'll simply move this, all this, because I am keeping side cover of 25 mm for this main reinforcement bar. So I'll move it from center to 0, x0, y0, z will be 25. Done. Now if you just check it over here, my computer have become very slow now. Okay, so now if I just show you this view, yeah, so it is lateral, it is quite okay, but vertically again I'll have to move it, because if you just check it over here, I'll have to keep the vertical cover also. So for vertical cover again I'll hide it, and the vertical cover is 25, so I'll have to move it 25 mm vertically. This point to 0, 25, 0. Done. Okay, hold on, I have made a mistake. The coordinate should not have been 0, 0, 25. It should have been, again I'll have to select this, I'll have to move this point to, my x will be 25, right, y will be again 25, and z will be not x, sorry, x will be 0, y will be 25, z will be 25. Now it's okay. Now if I just unhide this beam, done. Now if you check it with different views, if I just take YZ plane, it is perfect, and if I just take XY plane, it is not perfect. So from this side also I'll have to keep a spacing of 20. So the coordinate should have been x20, y25 and z25. So again I'll have to select it, select this, move it to x20, y25, z25. Done. Just want to check the coordinate once more. x20, y25, z25. Done. Now I'll have to again unhide the beam, apply, check the xy plane, yeah, perfect, yz plane, perfect, and if I just check xz plane, perfect, it's perfect. Now I'll have to create some partition, and that I'll create on the part only, so that I can fix the blocks where I'll be applying the loading condition. So for partition, go select the offset from plane and flip the direction, enter the value as 200. Yeah, perfect. And from here it will be 100, because the block was of this size, 100 by 6 by 100. So same I'll have to do it again for this side. I'll have to flip the direction, flip it, make it 200, and this pen it will be 100. This I'm just creating so that I can assign the block over here. And then the loading block will be spacing is 625 from each side. Loading is applied, so from, if I minus 625 minus 50, it is 575. So again select this, select 575, done. Here flip it, select 100 again for applying the load. First one was for applying the support, this one is for applying the load. 575, and then make it again 100. And then now I'll just create the partition using data plane. Select this, create partition, select this. Now create or select all the data planes to create the partitions one by one. Done. If you have not understood why I am creating this, now the only thing remaining is I'll have to make a steel block. In the paper over here you can see they have used 4 steel blocks for applying the load and support. So just go here, write it BLOCK block. It will be deformable, it will be of rectangular shape, the width will be 100 and depth will be 6, done, and it will be 100. Okay. So now I'll have to assign some property to it. So I'll be assigning steel property. Go to homogeneous, make a section of block, select steel, okay, block, okay. So for the block I have assigned steel property. Now I'll simply go to assembly. I'll have to bring that block to my assembly. I need to move it. Before that, what I'll do, I'll just go here, set all off. These are the 2 things right now I need. So it has been kept here, the block. You can select it like this, select the block, bring it over, bring it at the support, done. Okay, sorry, there is a mistake. I'll have to bring it a little bit at lower points. Over here, as you can see, it has been put inside, which is not correct. I have to select this block again, select that point and drag it here. Now done. Now I need to create another 3 blocks. For that, what I'll do, I'll use the linear pattern. Select the linear pattern, then select the instance that you want to copy, done. I'll simply give it a spacing of 100 and there is 100. So right now I have another 3 blocks. What I'll do, I'll just bring those blocks one by one to its position. The top one is for application of load, done. Select. My computer has become a little bit slow, done. So this is not a tough job. If you have any issue or any query regarding Abaqus, any type of modeling, whether you are from civil engineering or mechanical engineering department, does not matter. Whether you are working in any field or in Abaqus, just contact with me if you are having any issue, because the errors that we face is near about similar for all cases. This is where we struggle usually. Many of my clients only contact me just to solve the error. Yes, I do also provide the modeling support. So my blocks have been placed correctly. Now my job is to create. First thing is to step. Go to step. Go over here and create a dynamic step. I have created earlier, so you'll have to double click it, create, and select dynamic explicit, and I have given the name as dynamic explicit. That's all. Okay, now what I'll do, okay, let's just straight away go to the interactions, create interaction, surface to surface contact, so I'll give it as support, left side support. So this is the left side support, and this will be initial, surface to surface. Okay, now this is interaction, so left side load, interaction will be used for load. So here is asking me to select the first surface, so I'll select the first surface. This is used for hiding the other objects that are available on your model. Done. First surface, second surface will be my block. Done. Interaction property I have created previously. You just go to contact, create property. Here from select tangential behavior same, frictionless, and normal behavior hard contact. Just if you just press OK at the bottom, it will get contact property like this. So I have created previously, I haven't created again. This is what same I'll have to do it for the other support. So I'll just not support the loading point, I'll just copy it, and here modify the first surface. So for first surface, okay, here I have to select the second surface first because I don't need to do it again, else I'll have to hide the beam again. So this is just because of the convenience I'm doing. I'll select the second surface, and the first surface will be the beam. So for that I need to hide all these blocks. Done. So 2 interactions have been created. Now I'll have to tie the supports left side. I have to tie. For that, choose master surface. So for master surface, what I will do is I'll select the steel surface as master, top one is master, and slab surface will be my beam bottom. Done. Same I'll have to do it for the other support, so I'll just copy it. You can rename it, no issue. So this left surface first, I'll select this one, dismiss it. Done. And the master surface will be this one. Done. So I have tied interaction. There is one more thing that I have left. Do settle on unhide this blocks and beam, and just keep the reinforcement over here. go to create, go to embedded region. This is just for reinforcement bar. Select this, all the reinforcement bar, select the region, set all off, beam 1, and now select this beam. The host region will be the beam only. Leave everything like that. Okay, now what I'll do is I'll go to the load section. I'll assign some load, create load. It will be dynamic explicit. Sorry, this is boundary condition, not load. So let us first assign the boundary condition. It will be initial, select displacement rotation. So this point first, we set all on, apply. Select this face, bottom face of the steel plate. I need to make it hinge. So for hinge, all the rotations should be free, but what I'll do, I'll just constant the torsional rotation, that is UR3, and also vertical rotation, that is rotation about vertical axis, UR2. So only UR1 is free, which is nothing but the hinge support. I'll rename it to hinge. First again I'll have to do one more thing for roller. I'll rename it to roller. I'll have to select that face, just select this face. Done. For roller, except U3 will be free, U1 U2 will constrain, and the rotation about this one UR1 will be free, UR2 UR3 will be constant. So only horizontal direction movement, and UR1 I am keeping it as it is. Now the loads will be applied. For dynamic step, pressure, the load in the paper is not mentioned clearly, so here I will simply apply the load of it has been mentioned at 241 plus minus 34, so it was not clear how they have applied, so I'll just apply 2410 and I'll assign an amplitude. The amplitude you can create over here, tabular 0 for 0 and 1 for 1. So if you just click OK, you'll get the amplitude like this. You have to select the amplitude, click OK. So everything is completed. Go to mesh. Right now everything is completed. Go to mesh and select, make sure you have set all on, click apply, select everything and mesh it. First you'll have to assign mesh it, so it shows dependent part. So do one thing, just go here, select everything and make independent. Now assign mesh shed of what I'll do, I'll assign 15. You can go for final mesh also. For that, to decide the exact message, you'll have to mesh convergence study. Right now it looks quite okay. What I'll do, I'll just change some element property. For that, just hide all the blocks and beam except the reinforcement bar. Now select all the reinforcement bar, change the element type to truss. So over here, as you can just go there, so make it truss. If it is beam or whatever, if it is beam, make it to truss. Done. For all other parameters, okay, no need to do anything. Save the model. I hope everything is completed now. I'll just do a quick data check. See if my results, if my analysis is correct or not. It won't take much time. Let's see. So in the meantime, if you have any doubt, any query about this model, or even if you have any issue with any of your other models, you can contact with me. I have given my contact details over here in the description also. It is available. Okay, so it shows some issue. Okay, so this was just a minor issue. If you are modeling for the first time, you won't have any such issue. Previously I modeled it and there was some issue, so it is why I'm having this issue. You don't have to do it. Do not do it in your model, because if you are modeling for the first time, you don't have to do all these things. Even you'll not have such issues. This I'm getting because previously I tried to model it using rigid block, but there was some issue, which is why I had to change it. So previously when I was trying to model it using the rigid block, basically you'll have to assign uh, some boundary condition to the translation degree of freedom of each rigid body, but because I was applying the load, not the displacement, because the analysis was load control, so I had to leave this particular displacement of the rigid body free, so which is why Abaqus was not accepting it. Because of that I have this issue. So my check is completed. That means my model is perfectly working. What I'll do is I'll create two sets of node, and I request you to do it also, which I have created here. So just reaction at load point. So now what I'll be doing, set all on, apply, and you can select the reaction point. So for that, what I'll suggest to select any point from here. This is the load point. Done. And also from support also select any point like this. And now go to step, go to history output, and this one I have created previously. We need to select the sets from here, make it, if it is 200, make it 500, and select the reaction forces. This is what I have done. I'll click OK. I'll save the model and I'll submit for run. This I am doing just to extract the results once the modeling is completed. So thank you for tuning into my channel, and please don't forget to subscribe. I'll show you the results once the analysis is completed. For that time I'm just pausing the video. Once it is completed, I'll resume it. So just now I have checked that there is an issue. I need to change the load value, so you can just go to the load option, go here and change it to 241. Previously it was 2410, it is 241. Done. Okay, save it and again run it. So previously if your model is running, then just kill the model, change the load value from here and again run it. So my file is running and it has completed about 0.7 seconds. So let us wait for some more time. Hopefully it will get completed soon. So the analysis is completed. Now just right click on the job file and check the results. So if you just check the results, it looks quite perfectly fine. You can get this frame selector from here. Just check it, it's okay. So this is the deformed shape. If I just check the U, this is how it has been deformed. You can get the reaction force RF2 from here. Okay, if I just increase it, I need the reaction force RF2. So if you just increase the time duration for the simulation, you might get a better results. What I'll do, I'll just again the reaction of some other point. For that, just go to XY data, ODB files, select unique nodal. From the reaction forces, select RF2, and from here just select the point of your interest for plotting the reaction. Okay, so there is some issue. It would be better if you just select this node, because all the bottom nodes are fixed. So select any node from here and then plot it. Okay, so this is the loading diagram, and this has been simulated for 1 second. So if you just select simulate it for further version, you might get some more results. So this is what I have for the timing, and